page is this going on? 92. Okay, thank you. So we are going to talk about linear and angular speed, which can also be talked about as circular motion. And another word we could use for speed here is what? Velocity. You were right. Good job there. Okay, so it's also linear. Another way to say the exact same thing, or circular motion. So let's talk about the videos, but and the lighting is terrible, but it's better than if on this circle here, I have, if I do, I'm going to have a the outside point's going to travel farther than the inside point does, because that circle would be different linear distance, which means it would have a different linear speed. So in 1 minute, how many times it goes around, this one's going to have to go a lot faster to keep up with this one. This one's going to go a lot faster, I'm sorry, to keep up with this one. As far as angles are concerned, in one full revolution, they both end up right back here, right? So they're going to both travel to end up right back here in however many minutes, whatever, just the same number of revolutions. And so their angular speed is going to be the same. Their linear speed is the change in the distance over time. The angular speed is the change in the angle over time. They will have the same angle, 2 pi, and run revolution, but a different distance because turn the lights completely for you to watch this amazing video with Lego Man. Yes, I have to press and hold it. Hang on a second. There. So these are Lego Man on the turntable, and red guy. Yes. Linear slide because the circle is smaller. And the angular speed is the same because they are going through the same number of revolutions together. Okay, so you see, you can have the same linear speed. Good with that? Those are two different things. Okay, one has to do with angles, one has to do with length. Okay, and that's, I don't know why the lighting couldn't be better on this video, but that's all good. I think it gives you the point of it anyway. All right, so let's get the differences here. It says arc length, which we just finished doing. Arc length can be used to analyze circular path S with radius r. So it says the rate at which the object moves along the path is called linear speed, or v. Formula distance over time. That's basically what it is. Our distance in this case. This is arc length over time. All right, so then we have angular speed. It says the rate at which the central angle is changing is called the angular speed. And then this right here looks like a little curvy W. It's actually Greek letters. Get out your alphabet. Tell me which Greek letter and whether it's capital or lowercase. I bet they wouldn't steal them if they were in your notebook. All right. This right here, which Greek letter and is it capital or case? Omega. Y'all agree with that? Capital or lowercase? Lowercase. Here's the Greek alphabet. It's your lowercase omega. Looks like a curvy W. Okay? But it's not. All right. So, and, oh, that's right. Let's see. This right here, this is omega. So your angular speed formula is omega equals the change in the, which is theta, over time. Okay? So this is your zinc angle is the central angle over time. Okay. And the central angle, remember, just has the vertex at the center of the circle. It is the angles that we're talking about. The arc measure, which can be measured, like arc length, and measure different things. The arc measure, when we're talking about angles, is the same as the central angle. So the arc measure would be however many radians. That's the same as the central angle. So it's the same angles we've been talking about when we've been talking about theta. Okay, so let's find these two things here. So the bicycle tire with a radius of 14 inches rotates at a rate of 125 revolutions per minute. I gotta fix the board here. And we want to find the linear speed of the tire in inches per minute. All right, so I need the arc length first in order to do the linear speed. Linear speed is velocity, it's s over t. So I have to find s. Your arc length is r theta, right? That's what we did yesterday and the day before. What is your radius here? 14 inches. So it's 14 times. Now they can straight up give me theta like they did when we were doing arc length. Instead, it gave me the RPMs. Okay, so one revolution is one time around the circle. So one revolution would be how many radians? 2 pi. So one revolution is equal to 2 pi radians. So if I have the number of revolutions, all I have to do is multiply it by 2 pi. So theta, so that means that theta is equal to 2 pi times whatever your RPMs are. So it's going to be 14 times 2 pi times 125. Okay, because that 25 times, the 2 pi times 125 gives me my theta. Everybody with me? So then that means here, I'm going to get 14 times 250 pi. Now, some of you can look at those two numbers and you already know what they multiply to give me, but don't tell me. Those of you can do the shortcuts pretty easily. Some of you can do the shortcuts, but numbers like this might throw you off a little bit. I want to show you another way to kind of manipulate numbers. This is all number sense stuff. It has nothing to do with the actual content here, but the more you do it, the more all of this stuff starts to make sense. So I have 14 times 250. Now, one thing I can do is 10 times 250 and 4 times 250 and add them. That's fine. Or I can straight up multiply. But you can also break it down a little bit more to put it back together. So 14 is the same as 7 times 2. Would we agree with that? Times 250. What's 2 times 250? 500. So you've got 7 times 500. 7 times 5? 35. That gives me 3,500. Okay? Do you see? You can rearrange the numbers. It's just another. That works. 4 times 250 is 1,000. So you do it 3 times because that gets you to 12. And you got 2 more. That works too. Okay. So there's lots of different ways. And when I'm showing you these, I'm not saying you have to do this or this is the best way, but I want you to see that there are different ways so your mind can pick up on whatever makes the most sense to you and what you can see. You can also think in terms of quarters. If you have 14 quarters, like how much money do you have? And then just add the 0 on it. Okay. Same thing. Just whatever, and all our brains work a little bit differently, so go with whatever works. But so when you multiply this, however you do, you're going to end up with S equals 3,500 pi, and that is going to be in inches. So my velocity is 3,500 pi inches over. The RPMs were in inches or revolutions per minute. This is for every 1 minute. So for every 350 pi inches, there's 1 minute, which means then I write this as 3,500 pi inches per minute. And there's a reason that I'm having you write them like this first. We'll get to that in just a minute. So now we're going to find the angular speed of the tire in radians per minute. So this is omega equals theta over t. So you're not always going to be asked to find both of them at the same time like we just did here. So I know we already found theta within the other problem, so it would be fine to just use that, but we're going to pretend like we don't know that one for this first one. So if I had to do this and I had to find theta, remember all theta is this right here. It's just 2 pi times whatever the RPMs are, which is 125. So this gives me 250 pi radians. And although when we're talking about radians in other situations, we don't always put the units on it. We need to here because it's going to be part of the end units that are a rate. Okay, so then my omega is equal to the theta, which is 250 pi radians for every 1 minute. And then I have it in radians per minute like it asked me to, so it's 250 pi radians per minute. Everybody okay with all that? Easy enough? All right, good. So the next one, CD with a diameter of 120 millimeters rotates at a rate of 45 revolutions per minute. So we want to find the linear speed of the CD. So in order to find, thank you, thank you. Oh, but it still works. Like I ordered it pretty far. Oh, yeah. I wrote like 3 pins. Sure. Just dropping. This one works. Keep my fingers crossed. All right. So linear speed, that means I need the arc length. So S is equal to my radius. What's the radius here? 60 times theta. To find that, that's 2 pi 45. So 2 times 45 is 90 times 6. What's 9 times 6? 54. So 90 times 60 is 5,400 pi. All right, so this is 5,400 pi millimeters. So that means my velocity is 5,400 pi millimeters for every 1 minute. And I know that it's 1 minute because it came from this right here. Okay? And so then that's it. And I get 5,400 pi millimeters per minute. Okay. So then the next one. Find the angular speed of the CD in radians. So to do that, I have to have theta. Theta is 2 pi times the RPMs, which is 45. So that's going to give me 90 pi radians. So then omega is equal to that theta, which is 90 pi radians for every 1 minute. Nothing can be reduced here, so this is 90 pi radians per minute. So all 4 of these, we have written them like this, and then we end up writing them like this. Here's why I was making you do that each time. Because I know rates are not new to you, and I know conversions are not new to you. However, the connection that gets lost sometimes, I have found, is that when something that's given to you like this, when you go to do other things with it, I don't even know what happens sometimes. But I want you to make sure that you understand in any situation, not just for velocity and not just for today. If you are given something with a rate like this, and you need to do some conversions, then make it back into one fraction with the units. So if this is a whole number, well, it's not a whole number, but if it's not in a fractional form, then whatever this is, you can tie to this unit. So 90 pi radians over, and then since this is down there and you got the minute, it's for every 1 minute, because this is like 90 pi over 1, right? If this was 90 pi over 7, then I would do 90 pi radians over 7 minutes, and then I have a clean fraction that I can then move forward with. Does that make sense to you? So I'm okay with you like skipping to this step here, but in the notes, I want to make sure that you understand that you can go backwards this way. And sometimes you want it to be in this form to move forward like you're going to see on the next one. Okay? So let's look at 5 and you'll see what I'm talking about. It says a 16-inch diameter tire on a car is making 500 revolutions per minute. Find the linear speed of the tire in miles per hour. So it's only asking me for linear speed. So I need the arc length. S equals the radius. What's the radius? 8 times theta, so it would be 2 pi times what? 500. Okay. So 2 times 500 is 1,000 times 8 is going to give me 8,000 pi, and that would be inches. So my velocity then, my linear speed is going to be the arc length, which is 8,000 pi inches for every 1 minute, because this was revolutions per minute. However, the question is asking me for the linear speed in miles per hour. So me writing this as 8,000 pi inches per minute doesn't do me any good because I am not finished. If I know I'm finished, then it's fine. You can write it the other way. But I need to convert. So we're going to do dimensional analysis. You need to be very neat. I mean, not necessarily neat. Bad handwriting is bad handwriting. But you need to be clear on what you're doing for yourself. And the more you write this stuff out, the easier it all becomes in the end. If you just look at this, well, I'm supposed to multiply that by this and divide by this, whatever, great, knock yourself out. You don't have a calculator, and all you're doing is making your life harder and maybe missing something within that. So I don't want inches per minute. I'm taking care of the numerator first. I want it in miles per hour. So since this is inches here, I need inches in the denominator, so they're going to cancel out. I can easily go from inches to feet. How many inches are in a foot? 12. So 12 inches for every 1 foot. But I don't want feet. I want miles. So I put feet down here, so they'll cancel out. Miles up here. Okay? And so how many feet are in a mile? 5,000. 280. This is something you have to know. 5,280 feet for every 1 mile. So now my numerator is in miles. I'm good with the numerator. I want it in miles per hour. That denominator over there is minutes. So since minutes is in the denominator, I need it in the numerator so it'll cancel out. And minutes can go straight to hours for me. So I know there are 60 minutes for every 1 hour. And I now have miles per hour. Okay, everybody with me so far? I'm going to simplify in an organized fashion so it makes it a little bit easier on my brain. Now I can start just canceling the 8,000 with the 12, but if you look at everything that you have, does 12 divide it into 60 evenly? Yes. It does. How many times does 12 go to 60? 5. So I can knock that 12 completely out and make that 60 into 5. Okay. Then as far as 5,280 and 8,000, I don't necessarily know the biggest number. I do know that I can divide them both by 10, so I can knock out those zeros. And then they're both even, so I can divide them both by 2. So I'll do that and rewrite it so I don't get too much stuff going on here. So 800 divided by 2 would be 400, and it has a pi attached to it. And in the numerator, that's still times 5. Over in the denominator, when I take half of 528, what do I get? 264. Okay. So now it's a little bit cleaner to look at there. And then 5 is not going to divide into 264, but these are both evens. This can become 200. This can become 132. Can I divide them again? Yes, 132 divided by 2 is 66. And 200 is 100. Half of 66 is 33. And this is 50. You can always use bigger numbers along the way if you see them and you know them, but if not, you just keep knocking them down. Now I have a 50 and a 5 left in the numerator and a 33, which would be like a 3 and 11. Nothing's going to cancel out. So in the end, my velocity is 250 pi over 33, and that is miles per hour. Yes, because I don't think some people really know what those letters are when they do that. I'm fine with MPH as long as it makes sense. But if it's meters per hour, you write MPH, I'm not going to count. Like MPH only represents miles per hour. Otherwise, I don't know that you understand your units, but I'll be fine with that. Okay, okay with that? We good? All right, we're going to do 6 and 7, and we're going to stop, and I'm going to finish this tomorrow kind of like we did on the last 2 days, because I was running a little short on time in second period, and there was no reason to cram all this in one anyway. But I do want to work all these with you. So it says, circular saw blade with a diameter of 9 inches rotates at 2,800 revolutions per minute. Find the angular speed of the blade in radians per second. All right, so what do I need to find first? The radius. Do I even need the radius? What am I looking for? I'm looking for angular speed. Your angular speed is your omega. It's equal to theta over t. So I can go find arc length and all that stuff, but do I need it? No, I don't. I need theta and t. So theta is just equal to 2 pi times the RPMs, which are 2800. So what's 2 times 2800? 5600 pi. And that's theta, so it is in radians. Okay. Didn't label this as theta. I mean, maybe I'll confuse my units and stuff. Then to find omega, that's equal to my theta, which is 5600 pi radians for every 1 revolutions per minute. So every 1 minute. Do I want this revolutions per minute? No, I want it in, it's not revolutions, I'm sorry, it's radians. Radians, I want it in radians per second. So I have it in radians, I'm good. But I need it per second, so minutes up here, so they'll cancel out. I can convert minutes to seconds pretty easily. And so for 1 minute, there are 60 seconds. And that gives me radians per second. I can divide them both by 10 to get rid of those zeros. And then I can take half of 560. What's half of 560? 280. So I get 280 pi in the numerator divided by, and then since I divided this by 2, I can divide this by 2 and get 3. Can I divide 280 by 3? No, 2 plus 8 is 10, so I'm stuck. So that's it, and that is then radians per second. Okay, everybody get that? Yes? All right, so a windmill has blades that are 14 feet long. The windmill is rotating at 5 revolutions per second. Find the linear speed of the tips of the blades in miles per hour. So linear speed means I'm going to need arc length. So find my arc length. That's equal to r. What's the radius here? 14. Okay, 14 times theta. So that means I multiply it by 2 pi times the RPMs, or times the revolutions, which is 5. So 2 times 5 is 10, times 14 gives me 140 pi, and that was 14 feet, so it's 140 feet. Okay. So then my velocity is going to be 140 pi feet for every 1 what? Second. Not minute, the rest. It gave you the revolutions. It's rotating at 5 revolutions per second. So this is 140 pi feet per second is my velocity. What I want is miles per hour. So I'm going to have to convert. I'll start with the feet. So I know I can cancel the feet out, and feet can go directly to miles. How many feet per mile? 5,280. Yes, and that's a number that you need to know. Okay, so I've got my miles down, and then seconds, you could go directly to hours, but I think most of us would probably rather go step by step. So what the seconds would go in the numerator to cancel out. Seconds can go to minutes. So 60 seconds for every 1 minute. And then I can cancel the minutes, get to hours. And there are 60 minutes in 1 hour. So now I have it in miles per hour. Okay. And if you wanted to go, again, straight from seconds to hours, that's fine, but it's a little safer for some people not to jump that far. I don't know. Maybe because I make y'all write stuff down even when you hate it. Like, because this is pretty, you know, I know some of you don't need to write all this down all the time, but if you don't do it and I skip all those steps, it doesn't make any sense. So if you write it down, even when you think you're better than that, because I know some of you do, some of you don't, and you want to write everything down because you kind of know you need to. If you write it down and you can see it, it makes it a little bit more sense. Maybe that's why, I don't know. Maybe it's because it's not the first time you saw it. I don't know. Did it make you write down all the units and everything too like that? And explain to you why they're canceling out and why it goes in the numerator and denominator? Was that explained? Okay. So are we good on this though? We all got this now at least? All right. Everything else makes sense? That's good too. All right. So now we start to simplify a little bit. I can cancel out the, let's see, we'll cancel out the zeros here, or that 0 with this 0. And then I'll divide both of these by 2, so this would be 70. And 528 divided by 2 is what? Okay, so half of 500 is 50. Half of 28 is 14, so that's 264 when you put them together. Okay. And then can I divide this 6 and this 2? Like, I could keep going with this. I'm going to go over here first, and I have kind of a reason for that. But this is a small number. Maybe I can get rid of it completely. So I can divide both of these by 2. So this gives me 3, and then this would give me 132. Is 132 divisible by 3? Yes. So 3 goes to 1, so that's completely gone. And then I divide 132 by 3. 3 goes into 13 4 times with 1 left over, and then that's a 4 there. Okay. So I can take half of 60, and that becomes 30, and that becomes 22. Now, I could take half of 30 again, but let's look at what we're multiplying. Let's write down what we have left so far. We have this 70 pi times 30 over 22. I'm not necessarily saying you have to rewrite it at this step, but I don't want you to get lost in all your scratch work and lost in what you got up here. If I take half of both of these, which is fine, I'm going to end up with 70 times 15. Is it easier to multiply 70 times 30 or 70 times 15? 70 times 30, I would think, for most of us, right? So if you have things that end in 0, it's not a bad idea. Go ahead and multiply now and get, what's 70 times 30? 2100 pi over 20. Then I still need to reduce, but I know I need to reduce. But now taking half of that might have been easier than multiplying the other way. Okay, so again, if you kind of look at what you have instead of just pushing through and doing math as fast as you possibly can, you can these things up a little bit. So I cancel this out, make that 11, then half of 2100. So you can take half, what's half of 210? You have $210, you give me half of it. How much are you giving me? 105. Stick a 0 on there, that's 1050, so you don't do something weird with the zeros there. Then you can't divide anymore. Right? So that means that your velocity is 1050 pi over 11, and that would be miles per hour. Okay, are we good? If you take it slower and write the stuff down that should make sense to you, mark stuff out, think about how to make it easier on yourself instead of harder. It's fine to divide by bigger numbers if you see them. If you don't, just go step by step. There's no reason to sit there and try and figure out the biggest number you could possibly do. Okay, so we're going to stop here and pick up here. You should be able to at least get good on your homework, and then I'll just kind of explain a little bit more.